Okay, in this chapter we're gonna learn how to solve exponential equation and logarithmic equation. So in this video I'm gonna talk about the exponential equations. There are generally two cases for exponential equation. First one is the exponential equation with common base. This one is relatively easy to solve. The second one is on your next handout, which is the case of exponential equations with different bases. This one does not have any common basis, so this one involves a little more step. So let's look at the first example. What is the solution of this equation? So you look at the base, which is 16 and 8, and ask yourself if there is any common base. So 16 is what to the what power? Well, we know that's 2 to the 4th power is 16, and 8 is 2 to the 3rd power. So we do have common base, which is 2. So I'm gonna just, first step is to rewrite the terms with a common base of 2. So instead of 16, I'm just gonna write 2 to the 4th power. And I still have the power of 3x. On the right side, 8, I'll write that as 2 to the 3rd power. So I rewrote the terms with a common base of 2. Now we just use the power property of exponent. When you have exponent parenthesis another exponent, you just multiply these two. So you will get 2 to the power of 4 times 3x, which is 12x, is equal to 2 to the 3rd power. Okay, notice that the left side is equal to the right side, and then you also notice that these bases are equal. So if this number is equal to that number, and we already know the bases are 2, so that means since bases are equal, the power, the exponents must be equal too. So since the bases are equal, we're gonna set each base equal to each other. So that means 12x is equal to 3. Now you just solve for x, divide both sides by 12, x is 1 over 4. Okay, just to make sure our answer is correct, I'm just gonna plug in 1 over 4 back into our original equation. So the original equation was 16 to the 3x power is equal to 8. If I plug in 1 over 4 into x, I will get 16 to the power of 3 times 1 over 4, which is 3 over 4. Well, if I apply the exponent rules, the denominator becomes the index, so the 4th root of 16 to the power of 3, the top becomes the power. And if I simplify the inside the parentheses, 4th root of 16 is 2, because 2 to the 4th power is 16. So 2, and then I still have power of 3, and 2 to the 3rd power is 8. So left side indeed equals the right side. So we know this answer is correct. Okay, the second type of the problem, the exponential equation does not have any common base. So if you look at this equation, you see 15 and 285. Well, they look like they are both divisible by 5, but 15 is actually just 5 times 3. This one, if I divide it by 5, I will get 5 times 57. So it seems like we cannot express both numbers in terms of the same base like what we did here. So these are different cases. So because I cannot find any common base, I'm just gonna change that into logarithmic equation. The basic rule is that unless you can simplify and find the common base, basic rule for solving exponential equation is to change that to logarithmic equation. When you're solving the logarithmic equation, unless you can simplify, you want to change that to exponential equation. So let's convert that to logarithmic equation. So we know log base is this number 15, and the argument is the resulting number, which is 285, is equal to the power 3x. So we just change that to logarithmic equation. Now the next step is solving for x. Now we have 3x, so we divide both sides by 3. 3 cancels out. X is equal to divide by 3. Seems like I cannot simplify this one to a nice whole number either. So since I want to know how big that number is, actually I want to use the calculator to convert that to decimal. But the problem is, as you know, our calculators do not have the base of 15. We only have the base of 10 or the irrational number e. So that means I have to convert this to the base of 10. So we're gonna use the change of base formula. If you remember, that goes like this: b m goes to so the argument goes to the top, base goes to the bottom. So if I'm just gonna convert that, I will get, I'm just gonna deal with the top part first. So I will get log base 10, which I don't really have to write. The argument is 285, and the base goes to the bottom. It becomes the argument of the denominator. So I can just convert that and I will get some number. I'm just gonna pull out the calculator. So I'm typing log 285 divide by log 15. And it tells us that that value is about 2.087 something, and our x value that we are trying to find is that value divided by 3. So I'm just gonna divide the whole thing. I'm just gonna put parentheses so that it doesn't confuse us too much. So that value divided by 3 is equal to this value, which we can round that up to about the third decimal. So 696.